All right, so basically what you see here on the top, this is the hot block right there, the hot side of it.
Use the microphone.
Oh, all right. What you see right here on this top side right here is the hot side or the hot block. Right there you see your cartridge, your resistive cartridge heaters all along there to the left. The bottom block, as you see right here, our cold side, basically has this copper tubing feeding the whole thing. And these connectors come down to the bottom, and those connect directly up to the nest lab for it, or our active chiller for it. Under here, you'll see our actuator. Now, this isn't the actuator that we ordered. That one's still on back order right now. We're waiting for it, but this is a actuator that's in its stead, I should say. So basically, you would turn it on via these, and this compresses up and would sandwich the TEG right here. In my haste today, I forgot to bring a TEG, which would have obviously been a nice thing to see it in. Then after that, obviously, you'd seal the door. We still need to make some locking mechanism on that. This is the 4D touchscreen that I explained before. And then your pneumatic connector on the side right there. And your PLC is on the back connected to a DIN rail. So, yes.
What are you guys doing to align the TEG in the center of your block to make sure that you're getting...
We have for each different size TEG, we have different sandwiching materials for it. For two reasons. One, for alignment, like you had asked, and the other so we don't get undesired heat transfer between the two blocks.
Can you turn the touchscreen on?
I have no power to it right now. So, yes, but no.
What's the structure? Is it 80-20 that's containing the 1,600 pounds?
Yep, this is all 80-20 right there. The neat thing about 80-20 is on their site they actually show all their force calculations. So they have a force calculator so you can figure out if you're going to make it or not.
So have you been able to apply that kind of pressure in one form or another there yet? Have you tested that yet?
We've just tested this actuator right here. We haven't been able to get the full 12 or 1,600 pounds of force on it that we need. So until we get that actuator in, we're really limited.
Oh yeah, we've done like 200 or 300 on that.
What's regulating the water flow?
The water flow is via a nest lab, and the neat thing with a nest lab is an RS-232 connection can go to that, and you can program what the set points are for it. You can tell what you want the water flow rate to be. A whole bunch of information can be given to the nest lab.
Yeah, it's like a nest lab to commercial chiller.
Yep. All
Do you have a
right.
whole bunch of different thermocouples on the hot side?
We do. It's kind of hard to see. You might be able to see them. They're embedded in the block.
Yeah, they're from up
Just, let's see if we can. You can't really see the wiring all that well. One is actually inside the cartridge itself, and then there are 2 or 3 extraneous ones beyond that that are kind of layered on one side to it.
And you guys built that or fabricated, designed and fabricated?
Yeah, all of this we designed and fabricated ourselves.
And a TEG, if you run DC into a TEG, it's cool. It's hot on one side and cold on the other.
Cold on the other side. They use them a lot. A lot of medical devices are used for them. They use them for electronics. They have to keep at specific temperatures for tests. I think laser diodes they use them for them as well sometimes. Actually, the Voyager, that's how the Voyager is powered. Is they have a radioactive source on part of it, and that creates power in a thermoelectric generator type system like this.
No moving parts.
Yep, exactly. I mean, you get millions of cycles basically. It's semiconductors.
Yeah, Dan mentioned the applications of TEGs and some of the if you really look out, if you consider what a refrigerator does right now, we have a compressor that's running motors to compress things. If you just had a plate, you'd be going to a solid state refrigerator. Now, these would have to get cheaper to do that, but it's not hard to imagine going to have refrigerators that don't have moving parts and compressors running.
They make mini fridges with them.
So, just like LEDs have become pretty prevalent, I think that was a very good analogy where you get solid state lighting, you could get to solid state cooling. It's just a matter of getting that technology. So I think that's what they're trying to do with this company. Just starting at the infancy of it.
But it takes nasty chemicals.
It does. And that's one of the things they're trying to get with the bimetallic junctions being something that's different than these, you know, bismuth telluride or lead, you know, telluride. They're just nasty things to deal with. You know, and that's one of the reasons you don't want these units to overheat and start burning off. And there are, you know, some major things you want to try to avoid with these units.
Fire department already has to get special training to put out electric cars.
Exactly. All right, anything else?
Okay.
All right, thank you.